Hi, welcome back. So let's continue from where we ended at the use of the steam tables. If we can refer to the example 5-1 on page 71, you can see that there are two diagrams. One is pressure volume and temperature volume, and they both each have a hue, and you have constant temperature lines running along three different pressures: 90 bar, 5 bars, and 0.38 bars. Whereas the other diagram, you have constant pressure curves. Okay, going along here, 90 bar curve, 5 bar, and 0.38 bar. They actually represent the same thing. On your left hand side would be the so-called F line, saturated water line, and the saturated steam line, where dryness fraction is 0 on the left side and dryness fraction is 1 on the right hand side, as discussed. So the key is to find the specific volume of saturated water at point C and the dry saturated steam at points A and B. Right, so one is on the F line, the other two are on the G line. So let's go to C first. 5 bars. Okay, 5 bars, it will be on page 4. Alright, page 4. Page 4, where you run down the first column of pressure under 5 bars. Under 5 bars, okay, you should be able to see these numbers. Let me try to. Okay, what you're supposed to find is specific volume, right? So under 5 bars, okay, your specific volume at this VG, 0.3748 VG is actually here. Okay, the volume over here. This is VG. So we actually want to find BF at C. Okay. Under 5 bar, I think we can find something over here. Right. So if we look at the pressure, okay, saturation pressure along this line, 5 bars is between 4.76 and 6.18, right? So it's between the boiling point of 150 to 160 degrees. And the VF, the third column, will be around 0.10 something, right? So actually the difference is very small. Because why? Because if you notice, this is page 10, page 10 of the steam tables. If you notice, this VF, the unit for VF is not just meter cube per kilogram, it also has a 10 to the power of minus 2. Okay, so what does that mean? It means that your VF at 5 bars, okay, is around 0.1 something times 10 to the power of minus 2 meter cube per kilogram. Okay, so this is also equals to 0.001 meter cube per kilogram. Okay, if you do not find this familiar, let me try to let you see that specific volume is actually 1 over density. So what is the density of water? 1000, right? 1 over 1000, which is exactly 0.001. Okay, so that you see that when this steam is at the saturated liquid line, the F line, the density actually, the specific volume does not change much. The density does not change much. Okay, so you can just take this as an answer. Okay, so this would be So I'll be writing Vf at C, right, is equals to 0.001 meter cube per kilogram. Okay. Specific enthalpy. There we can go back to page 4 again, 5 bars. Okay, page 4, 5 bars. Specific enthalpy. You're asking for HF now. So where is HF? HF is this column over here. Answer is 640. Okay, so HF at C is 640 kilojoules per kilogram. And then UF at C is here. The fourth column over here is 639. Okay, 639 kilojoules per kilogram. So this is point C. Okay. For point B, 90 bars at the G line, along the G line. You can go to page 5. Okay, page 5, 90 bars. So this is at pressure 90 bars. Okay, then my volume here is the volume along the G line, so it is Vg. Okay, 0.0248. So Vg at B is 0.02048 meter cube per kilogram. Okay, and the enthalpy will be at Hg at B. Hg is this 2743. Okay, and Ug at B is this for 2559. Okay, 2559. And at A is also at the G line. Okay, so we're asking for Vg as well at A, which is 0.38 bars. So of course it's not going to be page 5. We need to go to something less than 1 bar, which is on page 3. Page 3, 0.38. You will have this. Okay, 0.38 bars. So my Vg will be this value, 4.189. 4.189 meter cube per kilogram. You see, do you realize that, let me see, the Vg is usually much bigger than Vf. Okay, why? Because as you expand to gas, right, for each kilogram of liquid, as it expands and turns into gas, this same kilogram will actually occupy a much bigger volume. That's from liquid to gas. Okay, so VGA is 4.189 compared to VFC is only 0.001. Okay, again, Hg will be this value. Hg will be 2634. HGA equals to 2634. Okay, and UGA is 2475. 2475. Okay, so this is how you solve it. Okay, I didn't expect this question to take quite some time, but anyway, it's alright. I'm going to jump to the next topic, and that is the dryness fraction equations. Okay, I like to call this the dryness fraction equations. This is actually on page 70. Okay, the first few formulas here. Okay, so this is what it's about. You know that previously we talked about the dryness fraction is x. Okay, is how dry is the steam. Okay, so once you know the fraction, right, between 0 and 1, how do you use it? With this fraction, I know that the point that we're talking about is somewhere under the hill, and we have F values and we have G values, okay, and X is in between, somewhere in between. So how do we find the value? So for example, if I have just an example, F is 100, okay, and Hg is 1000. So somewhere in between will be between 100 to 1000. If X is totally wet, X is 0, then the enthalpy will be this value. If X is totally dry, X is equals to 1, your enthalpy will be this value. If it is somewhere in between, let's say if X is 0.7, then how can I calculate? I can calculate the enthalpy by using this formula. X Hg minus Hf. Okay, so if we chuck in the values, you will get 1000 minus 100. Okay, so here you get 100, 900, 90 times 7, 630. So your answer will be 730. So this 730 is between 100 and 1000. Okay, you can just put, if X equals 0, just put inside, you realize that X is simply Hf. If X equals to 1 and you put this inside, you will realize that these two will cancel out and H will just be Hg. Alright, so the formula, right, for the others are internal energy and specific volume actually comes from the same kind of equation form. Okay, UF plus X, UG minus UF. Okay, volume as well, VG minus VF. Okay, let's write this thing out. Totally, HF plus X, Hg minus Hf. Okay, you will see that in the lecture notes or the book, this becomes UFG. Okay, it's actually the same. Okay, UFG is just UG minus UF. This is also HFG. It is from HF to HG, the difference. So HFG is actually also equals to HG minus HF. Okay. Now the key point to note is this. Okay. You remember just now I mentioned that the density, the specific volume of liquid is around 0.001, and then just now we got a value of along the G line of the gas, right, to be about 4 point something. Can you see that the difference is very big? If the difference is so big, it means that this one is very small and can be considered to be 0. Okay, so if we ignore this term, right, if we neglect, say that this term is negligible, you can literally cancel out, and what will remain will be what's written in the textbook or the lecture notes. V is equals to X VG. Okay, this is how this equation is being derived. You can still use this to find your specific volume using the same way. Alright.